Earth's rotation is beginning to slow in a way scientists say has no parallel in at least 3.6 million years, and climate change is the reason. Researchers have discovered that melting polar ice and glacier are subtly altering the speed at which our planet spins, making each day slightly longer. The change is tiny, measured in fractions of a millisecond, but the forces behind it are enormous and unlike anything seen in modern geological history. Every day, Earth completes one full rotation on its axis, creating the familiar 24-hour cycle. But this rotation has never been perfectly constant. The gravitational pull of the Moon, movements deep inside Earth's core, and even shifts in the atmosphere constantly influence the planet's spin. Now, scientists say human-driven climate change has become powerful enough to join, and eventually surpass, those natural forces. The new research, carried out by scientists at the University of Vienna and ETH Zurich, reveals that melting ice sheets are redistributing massive amounts of weight across the planet. Ice that was once concentrated near the poles is turning into water and flowing into the oceans, where it spreads toward the equator. This movement changes Earth's balance and slows its rotation, much like a spinning figure skater slows down when extending their arms outward. According to the study, the current rate of climate-driven day lengthening is about 1.33 milliseconds per century. While that may sound insignificant, the planetary scale forces required to create such a shift are staggering. Researchers estimate that around 1,000 gigatons of mass are effectively being transferred from the poles into the oceans. Professor Benedict Soja of ETH Zurich, one of the study's co-authors, explained the scale by comparing it to an enormous cube of ice placed over New York City. The cube would rise around 10 kilometers into the sky, taller than Mount Everest. In terms of energy, the change in Earth's rotational dynamics is comparable to the force associated with a magnitude 9 earthquake, though not in a destructive sense. To understand whether anything similar had happened in the distant past, scientists looked deep into Earth's geological history. They analyzed fossilized remains of tiny marine organisms called benthic foraminifera, which lived on the ocean floor millions of years ago. The chemical composition of their shells preserves evidence of ancient sea level changes, allowing researchers to estimate how Earth's rotation behaved over time. Using a specially developed machine learning system capable of handling the uncertainty of ancient geological data, the team reconstructed changes stretching back to the late Pliocene period, around 3.6 million years ago. Across that immense span of time, today's rapid climate-driven slowdown stood out clearly. The researchers did identify one rare event about 2 million years ago when Earth experienced a similar rate of rotational change. At that time, a combination of unstable ice sheets and a natural spike in carbon dioxide triggered widespread melting. But scientists stress that event was exceptional and naturally driven, while today's changes are being accelerated by human activity within just over a century. If greenhouse gas emissions continue to rise and the world remains heavily dependent on fossil fuels, researchers believe climate change could become the dominant force affecting Earth's rotation by the year 2100, even surpassing the Moon's gravitational influence. Although the practical effects are subtle, they are not meaningless. Modern technologies such as GPS systems, satellite communication, and spacecraft navigation rely on extremely precise timing. Even tiny changes in Earth's rotation must be accounted for in advanced scientific and technological systems. Beyond technology, scientists say the findings symbolize something even larger: humanity's growing influence over the entire Earth system. The same melting ice that is slowing Earth's spin is also contributing to rising sea levels, stronger storms, and increasingly extreme weather events that threaten communities around the world. The study ultimately delivers a striking conclusion. Human activity is no longer simply changing Earth's climate, it is now altering the very motion of the planet itself.